A very good morning to all of you. Today, I'm going to discuss about the hybridoma technology. It is a technique for monoclonal antibody production. Yesterday, I have told you the application of this animal cell culture that deals with the production of so many different useful compounds like TPA, like OKT3, like blood clotting factor 8, blood clotting factor 9, then erythropoietin. So this technique, it is very important and very useful in medical science for production of monoclonal antibody. So monoclonal antibody that is used for preparation of different type of detection kit. Okay, so just come to this slide. I'm discussing this slide regarding monoclonal antibody production, that is the hybridoma technology. That is just you take uh, antigen antigen, that is a protein that is responsible for production of antibody. If you are injecting an antigen, then only there is a production of antibody in your body. So antigen, it is a weak attenuated protein that can cause disease, but it is attenuated, that is very weak. So it is going to inject in the mice. After injection in the mice, after 2 or 3 weeks, there is a production of antibody starts. So spleen cell, so you are going to collect the spleen cell from the blood serum of the mice, and then side by side you maintain the cancerous cell, that is myeloma cell. So myeloma cell have immortal property. It will not die within a week or next week. It can survive up to 4 or 5 weeks, up to 1 month or 2 months or 6 months, like that. So the cancerous cell have positive importance here in this technology, that increase the longevity of the antibody. So antibody generally produced by myeloma cell, generally produced by a spleen cell, not myeloma cell, that is present in the spleen of the this mice. So what is the technique? Means fusion of myeloma cell, that is the cancerous cell, and the that is the spleen cell, just for production of monoclonal antibody. So why we are going to fuse this spleen cell for with cancerous cell? The cancerous cell has ability to survive for a longer period of time. That is the positive point of that cancerous cell. But cancerous cell have no ability to produce monoclonal antibody. That is, that property is only present in a spleen cell. So that is going to produce the antibody, but that antibody get positive characteristic, that is immortal property, after fusion with the cancerous cell. So how can you fuse the two cells, one a spleen cell, one myeloma cell? Which chemical is used for fusion, act as a fusion or fusion of two cells? Can you tell me, anyone? Anushka, a chemical that is used for fusion of two cells? Richa, Pratibha, can you give answer? A chemical that is used as fusion, means fusion of two cells, that is polyethylene glycol. It is a chemical, that is polyethylene glycol, that is used to fuse the myeloma cell and a spleen cell. So that fuse uh, cell, that is known as hybridoma. Now this hybridoma, that is used for production of particular antibody. So what is antigen? Antigen is a protein of that bacteria or virus. Antigen is the protein of that bacteria and virus. When you are injecting in mice, the antibody will produce against that antigen. That is the advantage. Means we are getting the antibody of that protein or virus of particular bacteria. We are getting the antibody after injecting the protein of that virus or that bacteria that can cause disease. So our main motto is just to produce particular antibody against particular virus or bacterial cell, just to stop the spreading of that disease. So main objective is to production of particular antibody. So that antigen, it should be very, if you want to produce the antibody against uh, any virus like coronavirus, so you will inject the protein of that coronavirus in the body of that mouse. Okay, that is means if you want to produce the vaccine, just like vaccine production, then that is the antibody, means you are going to inject the antibody through the vaccine. Okay, so main motto of this experiment or this technology is just to production of particular antibody against particular viral protein. So that viral protein act as antigen, and whenever you inject that antigen against of particular virus, only then we get a particular antibody, and that antibody can be utilized for treatment of different type of disease. So just see the injection is going on in this diagram. Again, of what is that antigen? That is the protein of that bacteria, protein of that virus. It can be a dangerous, it can cause dangerous disease, but our objective is just to produce antibody. So how can you get that antibody? After injecting the that antigen protein in that mice. And then why we are fusing with the cancerous cell? Because cancerous cell is immortal. It will not die even within a week or within a 2 week. So it can use for a longer period of time. Means antibody can be used for a longer period of time. That's why we are going to fuse the property of immortality that is coming from cancerous cell. So why we fuse the cancerous cell? Because it is going to enhance the longevity of that antibody that is produced by that spleen cell after injection of that antigen. Okay, now you can use that antibody for preparation of different type of diagnostic kit for the treatment of different type of disease, and then production of monoclonal antibody that is uh, for treatment of during kidney transplantation, that is immunosuppressive drug. So who had discovered this hybridoma technology? Who has discovered this hybridoma technology? That was discovered by George Kohler. It was discovered by George Kohler and Caesar Milstein. It was discovered by George Kohler and Caesar Milstein in 1975. That is the one of the most important technology for production of monoclonal antibody, and have got Nobel Prize for that hybridoma technology. Okay. So can you tell me which chemical is used as a fusion during that experiment? That is polyethylene glycol and calcium ion. And which medium is used for a screening of recombinant that is hybridoma cell? Hat H, capital H A T medium. So hat medium is very selective hypogen xanthine aminophthalein thymidine medium. So that is used for a screening of only hybrid cell, not myeloma cell and not normal spleen cell. So just see in this flow chart, means that is the hybridoma technology. First step is immunization of mice and selection of mice. Means just you immunize the mice. So what immunization means? Putting the antigen protein of particular bacteria or fungus or virus that can cause disease. And after 2 or 3 weeks, what happens, that antibody titer reach in the serum of that blood of that mice, and you remove the serum from the source of the cell. Okay, and then we get the antibody. So that is the main motto, is just to produce the monoclonal antibody. So why it is monoclonal? Because a particular antigen or particular virus is going to inject, act as antigen inside the mice as a through during that experiment. So it will produce the antibody against that particular virus only, that particular bacteria only. So if you are using that antibody for treatment of disease, then it is very easy. So generally, antigen, that is, it can be a whole organisms, it can be a small cell of that bacterial cell or viral cell, and then adjuvant, it will used as emulsifying agent just to release that amount slowly and slowly inside the body of mice. So it is, our motto is just to trigger the production of antibody against particular antigen, that is the protein, that is the protein of that bacteria, that virus. So first step is immunization of mice and selection of mice, that is the donor for generation of hybridoma. Then you remove the spleen cell. Okay, and then what happens, step 2, that is the that is the donors, you are going to grow the myeloma cell, preparation of myeloma cell, so that this myeloma cell, it will mix with the spleen cell to enhance the longevity. Okay, so high viability and rapid growth means it can increase the growth rate also, as well as it improve the longevity, viability for a longer period of time. That two character that is going to insert in the myeloma cell, inside the spleen cell from the myelomas. So that is the purpose for the fusion of the character of myeloma cell, that is enhance the longevity, that is the viability, that is the liveness of that spleen cell, and increase the growth rate of that spleen cell for maximum amount of production of monoclonal antibody. Next, uh, uh, fusion of myeloma cell with spleen cell. This is the most important steps of this hybridoma technology. That is, which chemical you can use for fusion, and you can also use Sendai virus instead of chemical, or you can also use the electrofusion techniques for the fusion of my spleen cell, because a spleen cell is a source for production of monoclonal antibody. You cannot expect the antibody from myeloma cell. You are going to insert the property of the high division and longevity, that is high viability for a longer duration of time from myeloma cell. That is the purpose of the myeloma cell. But actual production of antibody occur after triggering the production of antibody, after injecting the uh, that is the antigen of that particular bacteria or virus. So after fusion in presence of polyethylene glycol or using the Sendai virus or electrofusion, we get the hybrids. Now, how can you differentiate which one is the hybrid cell, which one is the myeloma cell, and which one is the spleen cell? So hat media, that is a very selective media, that is hypoxanthine, aminopterin, and thymidine. That is a very selective media for screening the only hybridoma cell. Rest both the other two cell, that is a spleen cell and myeloma cell, will not survive. Myeloma cell and a spleen cell will not survive inside that media. That's why we are using hat media, just to screen out the hybrid cell. Our objective is just to produce particular monoclonal antibody with high speed and that have high longevity, that can be used for a very long period of time. That's why we are selecting only hybrid cell, not myeloma cell, not spleen. So this is the mode. So just this is the explanation regarding how this BCL is going to produce that particular antibody, and that have immortality and longevity for very long duration. So this is the HGPRT, that is hypoxanthine guanine phosphoriboside transferrin, that is the Ig immunoglobulin thymidine kinase. So these are the molecular mechanism through which we are allowed to grow only hybridoma cell, not myeloma cell, not B cell inside the HAT media. Okay, so HGPRT is an enzyme help in purine metabolism. It can convert hypoxanthine to inosine, adenosine monophosphate to adenine, and xanthine to XII. So that is it is positive, and thymidine kinase it is also positive, means that is the functional. But myeloma cell, that is SGPRT negative, means that enzyme is absent in myeloma cell. That's why it is not survive in that HAT media. What I am telling, means myeloma cell have lacked such type of enzyme like SGPRT enzyme and thymidine kinase enzyme and immunoglobulin, that is absent in myeloma cell. That's why HAT media that cannot allow to grow the myeloma cell. Okay, and such type of growth that is coming from the hybridoma cell, because these are positive for all, that is positive for all, like SGPRT, immunoglobulin, and thymidine kinase. So this thymidine kinase and SGPRT enzyme, that is very very important enzyme for purine formation. If there is purine formation, only then that B cell will survive, otherwise it will not survive. Okay, so how we can get only hybridoma cell, because myeloma cell do not contain SGPRT enzyme like that, and immunoglobulin like that, and thymidine kinase enzyme like that. That's why it will not survive. But hybridoma cell will survive, that is going to fuse with that B cell. So this is the molecular mechanism, and that is the de novo pathway through which we can know the answer why hybridoma cell is going to survive. So can you tell me the what is the application of uh, hybridoma technology? It is used as a detection assay. You can produce so many monoclonal antibodies, and that can use for preparation of different type of kits, and you can purify the it can also be used for purification techniques. So everybody try to know gene identification. You can also use that technique for gene identification and disease therapy. I have already discussed OKT3, that OKT3 production only occur in presence of in the through the technique of hybridoma technology. And identification of cell surface risk markers, you can also identify with the help of hybridoma technology, and also used for drug delivery. So dissolving blood clot also removed through hybridoma technology. So these are the vast application of that hybridoma technology. So can I ask question? Can I ask question? What do you mean by hybridoma technology? What do you mean by hybridoma technology? Anyone? Anyone? Can you tell me what do you mean by hybridoma technology? It is a technique in which there is a fusion of a spleen cell that is coming from mice after injecting the antigen with myeloma cell. So how can you fuse? Please talk with me. This is not just like Ramayana Katha. So if you are interacting, only then you can understand. I am asking to all of you. Please tell me. Anushka, can you tell me what is hybridoma technology? Anushka, Pratibha, So it is a technique. It is a technique through which we are going to fuse the myeloma cell and a spleen cell. Why myeloma cell we fuse with a spleen cell? Because it is immortal and it will survive after production of monoclonal antibody. That monoclonal antibody will survive for longer period of time due to fusion of a spleen cell with myeloma cell, that is cancerous, and we can produce huge quantity of antibody because this myeloma cell have high rate of division and production. And second, why we use the spleen cell? Because a spleen cell is responsible for production of monoclonal antibody. We are not getting monoclonal antibody from myeloma cell, that is cancerous cell. Just next, which chemical is used as a chemical fusion? Anyone can answer? Anushka, can you give answer? Which chemical is used for fusion? Pratibha, कौन कौन आंसर दे सकता है?
The polyethylene glycol.
Yes, and other is chemical is calcium ion. Which virus is used to fuse the two cell? I have told you this in the slide. Sandai virus. Sandai virus. Which technique is used for fusion of two cell? Electrofusion. Okay, so you can fuse in any way, either through physical method or through use of virus, that is Sendai virus, or with the help of a chemical, that is polyethylene glycol and calcium ion. Why we are selecting the myeloma cell for fusion with a spleen cell? Why? Anyone? Silpa? Silpa, क्यों आपने सेलेक्ट किया myeloma cell?
Myeloma cell divides fastly.
यस, इट इज इमोर्टल, वो अजर अमर है, जिसके चलते जो भी एंटीबॉडी बनेगा so it can survive for a longer period of time and we can use that antibody for a longer period of time. It will not die. Okay, it will not degrade. Okay, just to enhance the longevity means of the spleen cell to produce huge quantity of monoclonal antibody means we are going to enhance the longevity survival of that spleen cell so that maximum amount of the antibody can be produced from a spleen cell. Are you getting my point? Means myeloma cell will enhance the longevity of the spleen cell, otherwise a spleen cell will die within a week. But when it is going to fuse with the myeloma cell, it can be survive for 3 week, 4 week, 5 week, and we can produce huge quantity of antibody. So in this slide, have you seen the syringe like diagram? Have you seen the syringe like diagram? That is what is this? What is this? Are you observing the slide? Are you observing the slide? Yes. So in the first diagram, what is this?
Antigen.
Antigen. What is antigen? It is a protein. It is a protein body of any bacteria, any virus that can cause disease. But the amount of that antigen is not a fatal, means dose of that antigen is not fatal, means it will not killed quickly, just it will trigger for the production of monoclonal antibody by the spleen cell of that mouse. So just it will initiate the production of monoclonal antibody. The amount or dose of that antigen is such that it will not kill that mice. It will it will trigger the production of monoclonal antibody against that antigen. So that is the motto, just to inject the antigen. It is a protein of particular virus, just like HIV virus, just like coronavirus, just like any virus. So or any bacteria that can cause disease. Okay, so when after 2 to 3 weeks it will start the formation of monoclonal antibody from the spleen cell. So you are getting the monoclonal antibody from the spleen cell. But if you are going to do that experiment in the lab, so you have to isolate. You have to isolate the what? You have to isolate the spleen cell. You have to isolate the spleen cell from the body of that mice, and then you have to fuse with the myeloma cell. So what is myeloma cell? What is myeloma cell? It is a cancerous cell. Myeloma cell, it is a cancerous cell. So can you tell me what is the advantage of cancerous cell or myeloma cell to fuse with the spleen cell? क्या advantage है?
Immortal.
Means it is immortal, and the rate of speed of the multiplication of that property is going to fuse with the spleen cell. Means rate of multiplication or rate of production, means it is going to rate of multiplication is very high of the cancerous cell. That property is going to insert in my spleen cell. That's why it will give the longevity to the spleen cell, so that the spleen cell will produce huge quantity of monoclonal antibody against that antigen. So what type of antigen you are selecting, that will decide the production of particular antibody. Means you are taking the antigen of coronavirus, then you get the antibody of that coronavirus. If you are taking the antigen, that is the protein of that the other virus, like the HIV virus, then we are expecting to get the antibody of that HIV virus, or any bacterial cell, then we get the antibody of that bacterial cell. Means polio virus, then antibody of that means if you are injecting the protein of polio virus, then we get the antibody of that polio virus. So this is the, it will depend what type of antigen you are going to inject in the mice of the body of the mice body. Then when it is going to fuse, when the spleen cell is going to fuse with myeloma cell, then it will optimize the production of antibody. So this is the motto. And why I have already explained which chemical is used and what technique that is used to make the hybridoma cell. That is chemical is polyethylene glycol, or technique is electrofusion, or physical technique, or virus that is used for fusion of two cells, that is a spleen cell and myeloma cell, that is Sendai virus. So in which medium it is growth, you can select this one is the hybrid cell, or this one is the spleen cell, or this one is the myeloma cell. So hat medium, you must know the hat medium. What is the full form of hat? Please write down: hypoxanthine, aminopterin, thymidine. Hypoxanthine, aminopterin, thymidine. So that is the hat medium that will allow only the hybrid cell please grow, and rest it will kill by that hat medium. So it will allow the growth of only hybrid cell, not the myeloma cell, not the spleen cell. Okay, it is clear to all of you what is the full form of hat? Anyone can reply? What is the full form of hat? Please reply. Richa, can you reply full form of hat? Hypoxanthine, aminopterin, thymidine. Silpa, please reply. What is the full form of hat?
Sir, wait a
Hypoxanthine, aminopterin, thymidine. Please reply. Repeat that.
hypoxanthine,
Yes. Then A for H for hypoxanthine, A for aminopterin, T for
aminopterin,
thymidine.
thymidine,
So please repeat that everyone. H for H,
hypoxanthine,
A for
aminopterin,
T for.
thymidine.
So that media is only select the hybrid cell, not the spleen cell, not the myeloma cell. What is the full form of PEG? What is the full form? Yes, polyethylene glycol. What is the full form of PEG? Polyethylene
Polyethylene glycol.
Right. So this is very very important point in the hybridoma technology. Who had discovered the hybridoma technology? Who had discovered the hybridoma technology? George Kohler and Cesar Milstein. George Kohler and Cesar Milstein. When they have discovered this hybridoma technology in 1975. What is the purpose? Just to produce the particular antibody, that is monoclonal antibody. Means monoclonal antibody is very specific. If you are going to produce monoclonal antibody against polio virus, it will not use for the other virus like coronavirus. If you are going to produce the monoclonal antibody for coronavirus, then it will not use for the polio virus. Okay, so these are the specific, that's why I'm telling that it is monoclonal antibody. What is the application of monoclonal antibody production? It is used for treatment of different type of disease like immunosuppressive drug, that is the OKT3. Okay, so immunosuppressive drug that is used, immunosuppressive drug, it is also used for treatment of different disease like immunosuppressive drug, that is during kidney transplantation. Second, that is used as a used to detection of biomolecules like used in ELISA kit. It is used in ELISA. You know ELISA kit? It is a viral detection kit to detect the HIV virus or detect the any virus protein. So you are going to put the antibody on the kit, and when you are pouring the serum, then it will quickly diagnose whether the antibody, that virus, is present or not in your blood. So it is used for detection assay. Okay. So uh, you can used for detect used for making a different type of detection kit like ELISA kit, like pregnancy test kit, like other kits for the detection of different type of disease. Then purification technique means you are going to purify the any biomolecule like protein through use in western blotting. You can use the western blotting. You can make the kit for the western blotting where they use of monoclonal antibody to detect the protein of particular virus. Then also used for gene identification technique. Then I have already told you the disease therapy that is used for detection during kidney transplantation, act as immunosuppressive drugs. Then identification of cell surface marker. So these are the different application of this hybridoma technology, also used for drug delivery and dissolving blood clots. So these are the application part and advantage. Hybridoma serve as immortal source of hybrid monoclonal antibody because it is going to enhance the longevity of that due to fusion of the property of the myeloma cell. Same quantity of antibody is maintained among the different production batches. A speed, sensitivity and specificity of that assay is very useful. Then selection help to identify the right clones. Okay, so these are the application advantage. Then high reproducible and scalable unlimited production. Then antigen or immunogen need not be pure. Okay, so these are the advantage of that hybridoma technology. Okay, next, if you see the disadvantage, time consuming project, it will take time of 6 to 9 months. It is very expensive. Hybridoma culture may be subject to contamination. There may be chance of contamination. So you have to maintain the your animal cell culture lab very clean environment. It should be, you have to maintain the sterile condition of the every equipment, every instrument, every chemicals. And a small peptide and fragment antigen may not be good. Antigen monoclonal antibody may not recognize the original antigen. So these are the so many disadvantages. So these are the what are the application of monoclonal antibody or hybridoma technology. That is the main point of that topic. And who had discovered the monoclonal antibody? So if you have any question, you can ask to me. कोई क्वेश्चन है आपके मन में तो आप पूछ सकते हो. कोई है क्वेश्चन? एनी क्वेश्चन?
Sir.
अगर है तो आप पूछ सकते हैं. व्हाट इज हाइब्रिडोमा टेक्नोलॉजी, हु हैड डिस्कवर्ड द हाइब्रिडोमा टेक्नोलॉजी, एंड what is the advantage of hybridoma technology? Okay, so who had discovered the hybridoma technology? किसने किया है?
George Kohler.
George Kohler and Caesar Milstein. George Kohler and Caesar Milstein has discovered the hybridoma technology. So which chemical is used for fusion of two cell, myeloma cell and spleen cell? It is very easy question. कौन सा केमिकल है?
Polyethylene glycol.
एंड कौन सा आयन? आयन कौन सा है?
Calcium.
वेरी गुड. एंड which virus is used to fusion of two cells? कौन सा वायरस किया जाता है दो सेल को फ्यूज करने के लिए? Sandai virus. Sandai virus is used for fusion of two cells. Okay, so this is the advantage. Means in which media you are going to screen the hybrid cell? In which media you are going to screen the hybrid cell? Can you tell me anyone? कोई बता सकता है कि किस मीडिया में आप हाइब्रिड सेल को पहचान पाएंगे? HAT media. You know, hypoxanthine, aminopterin, thymidine. Hypoxanthine, aminopterin, thymidine. Hypoxanthine, aminopterin, thymidine media. Okay, so these are the chemical that is involved. These are the chemical that is involved in hybridoma technology. So you must try to learn what is the application of hybridoma technology and what is OKT3. Anyone?
Immunosuppressive drug.
Immunosuppressive drug. What is the use of that immunosuppressive drug?
Kidney transplantation. Formation of RBC.
Means used during kidney transplantation. If you are not taking the immunosuppressive drug, in that situation your body will not accept the kidney. Okay, your body will not accept the kidney. So I am talking about the hybridoma technology, that is we are getting the therapeutic antibody production, that is OKT3. OKT3 is therapeutic monoclonal antibody. Second, we are going to produce so many different type of kits, just like ELISA kit. You know what is ELISA kit? आपको पता है एलाइजा किट क्या है? बताओ, कोई बता सकते हो एलाइजा किट क्या है? बोलिए.
This is for detection of HIV.
Means just for detection of HIV. That is. So this is the hybridoma technology. I am telling that is who had discovered hybridoma.